Now we are going to start 15th practical of katakoda docker practical series. The 15th one is orchestration using Docker Compose. That practical is how to use Docker Compose to orchestration multiple container applications. Now I'm going to start the scenario. In here, when working with multiple containers, it can be difficult to manage the starting along with the configuration of variables and links. To solve this problem, Docker has a tool called Docker Compose to manage the orchestration of launching of containers. This environment has the latest Docker Compose installed. Uh, from this site, you can have knowledge to how the site has instruction to install this into your local environment. Mm, then I'm going to start this scenario. The first step is defining first container. Um, Docker Compose is based on Docker Compose file. This file defines all of the containers and settings you need to launch. Class does the properties map now use. Task define first container in this scenario. Then the second step is defining settings. Compose supports all of the properties. To link two containers together to specify a link's property and list required connection. For example, the following would link to the Redis source container defined in the same file and assigns to alias. The same format is used for other properties such as the next step is it's a third step, defining second container. The previous step we used to Docker file in the current directory as the base for our container in this step, we want to use an existing image from Docker Hub as a second container. To find the second container, you simply use the same format as before. New YAML format is flexible enough to define multiple containers within the same file. Defining second container. Define the second container with the same name release which the image release following. With the created docker compose.yaml can launch all the applications with the same Then the fifth step is Docker management. Not only can Docker Compose manage starting containers, but it also provides a way to manage all the containers using single command. For example, to see the details of the launched containers, you can use yes, Compose. Not only Docker Compose manage starting containers, but it also provides a way to manage all. To access all logs via a single stream, you use Docker Compose logs. Other commands follows the same. Please discover them by typing. The sixth step is Docker scale. What is Docker scale? As a Docker Compose understands how to launch your application containers. It can also be used to scale the number of containers running. The scale option allows you to specify the service and then the number of instances you want. If the number is greater than instance already running, then launch additional container. Then so Docker Compose understand how much. Docker stop. The seventh step is Docker stop. When we launched the application to stop a set of containers, you can use this command docker compose stop. To remove all the containers, use the command to remove all the containers. Docker compose remove. In this scenario, we explored how can we how can use Docker Compose to manage the orchestration of multiple container applications. I'm going to move to a next scenario. That is C container metrics with Docker stats. In here, it gains insights into CPU, memory, and network input output of your running containers. C container metrics with Docker stats. I'm going to start the scenario. Uh, in here, when running containers in production, it is important to monitor their runtime metrics such as CPU usage and memory to ensure they are behaving as expected. These metrics can also help diagnose issues if they occur. In this scenario, we'll explore the built-in metrics provided by Docker to give additional visibility to the running containers. In future, we'll investigate more details about running Docker in production. I'm going to start the scenario. Uh, the first step is a single container. The environment has a container running with the name Nginx. You can find the stats for the container by using this is the command to find the stats of the container. Nginx. This launch a terminal window which refresh itself with live data from the container. It shows the CPU usage, memory usage, limit, percentage of memory, control C to stop running. Continue. Uh, the second step is a multiple container. The built-in Docker allows you to provide multiple names slash and display their stats within a single window. The environment now has three connected containers running. To view the stats for all these containers, you can use pipes and sags. A pipe passes the output from one command into the input of another, while sags allows you to provide this input as an argument to a command. By commanding the two, we can take the list of all our running containers provided by Docker ps and use them as the argument for Docker stats. This gives us an overview of the entire machine containers. Control C to quit. Okay. In this scenario, we explored how you can gain more visibility into the CPU, memory, and I/O of input-output of running containers to ensure it's working as expected and to diagnose problems. In future scenarios, we'll investigate how these metrics APIs can be combined to create additional insight and dashboards. Now moving to the next scenario. Mm, it's uh, the next scenario is creating optimized Docker image using multi-stage builds. Uh, going to start that scenario. In this scenario, you will learn how to use the multi-stage build functionality to make smaller, more optimized images. The features is ideal for deploying languages such as Golang as containers. Golang. By having multi-stage builds, the first stage can build the Golang binary using a large Docker image as the base. In the second stage, the newly built binary can be deployed using much smaller base image. The end result is an optimized Docker image. Creating optimized Docker image using multi-stage build-ins. The first step is create Docker file. Multi-stage features allows a single Docker file to contain multiple stages in order to produce the desired optimized Docker image. Previously, the problem would have been solved with two Docker files. One file would have the steps to build the binary and artifacts using development containers. The second would be optimized for the production tools by removing the development tool in the production image. You reproduce the attack surface and improve the deployment time. Code start by deploying same HTTP server. This currently using this scenario will create new Docker file that allows you to use multi-stage Docker file. Using the editor, create multi-stage Docker file. First stage using the Golang SDK to build binary. The second stage copies the to optimize Docker image. There are currently discussion about improving the syntax that you can follow at this link. The next step is build a multi-stage Docker image. With the new syntax for the Docker file in place, the build process is identical to previously. Let's create a desired Docker image using the build command. Docker build. The result will be two images, one untagged that was used for the first stage and the second smaller image or target image. If you receive the error, copy. Docker images. Uh, the third step is test image. The image can be launched and deployed without any changes required. Then the next scenario is formatting PS output. In here, we learn how to format the outputs of Docker PS and inspect. In this scenario, you will learn how to use the format parameters to the pretty printout from the Docker PS and Docker inspect. Start scenario. Names and images as a table view. The first example, the format of can be formatted to only display the information relevant to you. Start example. Start function. Start by launching example container by this command. Format the standard Docker PS command. Output the name, image used command, uptime and port information. Status created date command, container ID. To limit which columns displayed use the format parameter. The parameter allows pretty printing using core template syntax. As it's using geo template, it includes helper functions. Example 2, list IP addresses. Uh, However, the format parameters allow supports displaying data that is already exposed via the Docker PS command. If you want to include additional information such as the IP address of the container, then the data needs to come via Docker inspect. Thankfully, the Docker inspect also supports pretty printing the results via a Go template. The container IDs from Docker PAs can be piped into Docker inspect. The format parameter can then access all of the container's information. Here is an example of listing all the IP addresses for the running containers. And the next, there is 20th practical of katakoda Docker practical series. It is Learn Docker Swarm 101. In here we learn how to manage clusters using Docker Swarm mode. I'm going to start this scenario. Mm, In this scenario, you will learn how to initialize Docker Swarm mode cluster and deploy networked containers using built-in Docker orchestration. The environment has been configured with two Docker hosts. What is swarm mode? In 1.12, Docker introduced swarm mode. Swarm mode enables the ability to deploy containers across multiple Docker hosts using over-layer networks for service discovery with built-in load balancer for scaling the services. Swarm mode is managed as part of Docker. Swarm mode is managed as a part of Docker CLI. The making it a seamless experience to Docker ecosystem. The key concepts: Docker Swarm mode introduce three new concepts which we will explore in this scenario. That is node services and load balancing. A node is an instance of Docker Docker engine connected to Swarm. Nodes are either managers or workers. Managers schedule which containers to run where. Workers execute tasks. By default, managers are also workers. Services are service is a high level concept. leading to the collection of tasks to be executed by workers. An example of this an HTTP server running as a Docker container on three nodes. Load balancing. The Docker includes a load balancer to process requests across all containers in the service. This scenario will help you learn how to deploy this new concept. The first step is initialize swarm mode. After running the command, the Docker engine knows how to scaling across step. In the next step, we'll add more nodes and deploy containers across this host. Join cluster. With the swarm mode enabled, it is possible to add On the second was the join the cluster manager will automatically accept. The third step is create overlay network. Overlay network. So introduce an import. The following command will create a new overlay network called Skynet. The fourth step is deploy service. By default, our use spread replication mode for deciding which containers should run on which hosts. Spread representation. uh, for ensuring declaration and last. Finally, we load balance to together on port 8 is sending an HTTP request to any of the nodes in the cluster. You can view the services running on the cluster using CLI command. As containers are started, you will see them using the PS. You should see one instance of the container on each host. Containers on the first host. List containers on the second host. If we issue an HTTP request to the public port, it will be processed by the two containers. Inspect the fifth step is inspect state. The service concepts allows you to inspect the health and state of your cluster and the running applications. You can view the list of all the tasks associated with the service across the cluster. In this case, each task is a container. Uh, Docker service PS HTTP. You can view the details and configuration of service via this command. One each node you can ask what task is it is currently running. Self refers to the manager node later. Using the ID of a node, you can query individual hosts. In the next step, we will scale the services to run more instances of the container. The sixth step is scale service. Service to scale how many instances of task. First, the last instance to containers are running it. Or remove containers as required at the moment the scaling is. The API could be hooked up. At present, we have two load balance containers which are processing a request curl docker. The command below will scale our HTTP service to be running across 5 containers. On each host, you will see additional nodes being started. The load balance will automatically be updated. Request will now be processed across the new containers. Try issuing more commands via curl docker. The scaling size down to see the result. The result of this scenario is two-node swarm mode cluster which can run load balance containers that can be scaled up and down. Now I'm moving to next scenario. It is Docker swarm mode playground. Docker is an open source project that automates the deployment of applications using containers, providing an additional layers of abstraction and automation on top of Linux. This playground provides a personalized, sandboxed environment for you to learn, explore Docker. What is playgrounds? Playgrounds give you a configured environment to start playing and exploring using an unstructured learning approach. Playgrounds are great for experimenting and trying samples. To learn more about the technology, then start with one of our labs. As a one step, create swarm class to initialize Docker swarm. This is the command. Then join Docker swarm. Create overlay network. Docker network create. Thanks for watching our Katakoda Docker series. We'll meet in another series of Katakoda. Thank you.